So we're going to identify and classify the discontinuities or restricted values of the graph. So we have two of them. We have x equals 3 and we have x equals -2. What does x equals 3 cause? You can even look at the picture if you want to. That's a hole. So that would be called a removable point discontinuity. And what's going on at x equals -2? That's an asymptote. That's right. If it's an asymptote, then it's a non-removable infinite discontinuity. So this is just driving that home again. What factor cancels out and what type of discontinuity occurs? Well, when it cancels out, that is the removable discontinuity. Again, just kind of driving it home. And what factor does not cancel out the denominator? And what type of discontinuity occurs at this one? That's the other one. So that's x equals -2, and that's the non-removable, or the asymptote, infinite discontinuity. Okay, I want you to try to do g of x. Just kind of on your own. You can, of course, reference the picture. I picked one without a number in it, so you didn't have to do the long no-fuss method. Fill out that row. for g of x, that will be bigger so we can see it. Factor that for me, Jenna.
X plus 3 and x plus 1 over x plus 3 and x minus 1.
Okay, good. Yeah, two numbers to multiply to give you 3, but add to give you 4, 3 and 1. And on bottom, two numbers to multiply to give you -3, but the add to give you 2 or 3 and -1. Good. So then what are the restricted values, Becca?
X plus 3 equals 0, x equals -3, x minus 1 equals 0, x equals 1.
Good. So basically you just set the bottom equal to 0, and those two are your restricted values. Plus you could also look at the graph. They gave you a graph of these. So you can look at it and tell which one to give you an asymptote or a whole. Okay, so then what's left when, what does it say? Rewrite the function in simplified form. So, Donna, after I cancel out what can be canceled in here, what's left?
X plus 1 over x minus 1.
Very good. Okay, we have two restricted values. Tell me what kind of discontinuities they are, Justin.
X equals -3 is a removable point.
Yep.
X equals 1 is non-removable.
Good. And then it's just the same thing over again. X equals -3 is indeed removable because it's the one that cancels. It's just wanting you to go from looking at the picture to seeing what's going on here. And x equals 1 is the non-removable. Good. Any questions on how to do that table so far? Okay, let's flip it over because the rest of them are the same pretty much. Flip it over. And what we've been saying, we're going to write down up here at the top so we have it. First off, discontinuities, of course, occur or happen at restricted values. Discontinuities occur at restricted values of rational functions. Then removable point discontinuities, which are holes in the graph, occur at restricted values whose factors cancel. Again, this is stuff we already figured out on the last thing. We're just writing it down so we have a list to go to. And then non-removable infinite discontinuities, also known as vertical asymptotes. occur at restricted values whose factors do not cancel